these are notes on phase change and heating curves. So the last time we took notes on phase change. So now we're going to add in another layer to that, and we're going to talk about heating curves and how we can analyze the phase change. So this is more or less what you should have gotten for your heating curve for water, with a couple of exceptions. When I took my data, I started with ice that was below 0. So like I took it right out of the freezer. And I had kind of a different way of measuring it. So you probably won't have this portion right here on your graph. Okay, yours probably starts off somewhere around here, like 0 or 1. And probably stays there for a few points before it kind of swoops way, 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 way up, and then finally levels off around 100. Now in class, most of yours leveled off around 95 or 96 rather than 100, even though water's true boiling temperature is 100. So there's a couple of reasons for that we don't need to get into in too much detail, but if you're curious, we can certainly talk about them in class. So let me kind of erase here. Okay, or not. All right, so let's look at the different parts of this. So right here is where the ice is melting. And for a lot of you, yours probably went straight up instead of having like a little leveled off place. Some of you I know have a leveled off place. It kind of depends on how much you were stirring your ice water. But you should have kind of a leveled off place at the beginning. And then up here where the water begins to boil, you should have another leveled off place. So what we're learning is that when something is going through a phase change, it's either going from solid to liquid or liquid to gas, or vice versa, going from gas to liquid and then liquid to solid, that there's no temperature change. And we're going to talk about why in a little bit. So then we can also find the states of matter. So down here, the state of matter is solid. Okay, so down here below the melting point, we're going to have a solid. That makes sense. This is what I took right out of the freezer. Then anywhere between melt and boil, we're going to have a liquid. And you should see that on your observations part, that that's where you had your liquid. Now, if we were to somehow capture the gas that was produced, right? So that's water in those bubbles, water gas, and then it goes out into the atmosphere. But if we could capture it and keep heating it up, we should find that we could continue to raise that temperature, but we can't do it with what's in our beaker. We have to do it with the collected gas, which is really hard to do. And so that's where our gas would be. So this is sort of a general heating curve, and you can tell it's for water because here, this would be the boiling temperature, and that's 100 degrees Celsius. And here, this would be the melting temperature, and that's 0 degrees Celsius. Now, where would we put in condensing and freezing? If we had, say, instead of going from solid to liquid to gas, we were going from gas to liquid to solid, where would those go in? So go ahead, pause the video, take a second to think about that. All right, so remember that condensing is the opposite of boiling, and freezing is the opposite of melting. So just as we go from liquid to gas at 100 degrees, if we're starting with our gas, once we cooled it down to 100, then it would start to condense. And so you would see the condensing exactly where you see the boiling. So now what do you think for freezing? Freezing would be exactly the opposite of melting. So if we had liquid water, we'd cool it down, 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 cool it down. And then here, this is where it would begin to freeze. And then if we continue to cool it down, it would be solid the whole rest of the way down. And so this is a general heating curve for water. And one of the questions is, so if the temperature is not increasing here, and the temperature is not increasing here as it boils, where's all that energy going? So the key to that is remembering back when we looked at how liquids and solids and gases, how those particles, those molecules of water are connected. And if you remember, gases, the molecules aren't touching at all. So here, the energy is going to break the molecules apart, break those water particles apart, so that they can move as a gas. All right, so let's now look at a different heating curve. This is a heating curve for a mystery substance. We're going to call it substance X for right now. And you can see it's got a couple of the same features as the water, but there's also a couple of different features. So what I want you to do is I want you to use this graph to determine the melting point, the boiling point, the freezing point, and the condensation point of this substance. And when we say point, when we talk about a melting point, we're talking about a temperature in degrees Celsius. So you're reading the graph to figure that out. So my advice to you is, again, to pause the video, see if you can figure it out, and then look at the answers. All right, so first let's start with the melting point. Let's go back to what we know. We know down here that we're going to have a solid. We know in the middle we're going to have a liquid. Sorry, that was my attempt at a cursive L. And then we know up here we're going to have a gas. So melting is going between solid and liquid, and I know the temperature doesn't change when something melts, so this must be the melting temperature. So if I kind of go back over to the axis here as best I can, that's maybe somewhere around, it's between 0 and 50. So we're going to say the melting point is about 25 degrees Celsius. Okay? So now the boiling point, I know boiling is going from liquid to gas, and I know the temperature doesn't change when it goes between liquid and gas, so this has got to be my boiling point here. And if I trace that over, so that's going to be 200 degrees Celsius. Okay? So now if I want my freezing point, if I remember from before, one of my tricks is I know my freezing point is just the opposite of my melting point, so it's got to be 25 degrees. But I also know that it goes from liquid to solid, and the temperature doesn't change, so, right, it's got to be this line again. So that's my 25 degrees Celsius. And then my condensation point goes from gas to liquid. It's where the temperature doesn't change, and so that, again, must be my 200 degrees Celsius. When I get a new computer, I want to get a touch screen so I don't have to worry about the mouse. All right. So you can look at a heating curve for any substance and know what its melting and boiling point is. And then, because melting and boiling points don't change, right? So if we go back to water, if I had like a mystery substance and I melted it, let's say it were solid and I melted it, and it melted at 0 degrees, then I would know it must be water. Because just like density, you could figure out what the density, or what a substance is based on its density, you can also figure out what a substance is based on its melting point and boiling point, or condensation point and freezing point. So remember, we talked about properties of matter, and we said density is a property of matter, so is the temperature when it melts and the temperature when it's boiled. And you can tell a lot about a substance from that, or you can like identify a mystery substance from that. All right, make sure you understand what we've talked about and ask questions if you don't.